thinking we probably can talk about
Which
it.
ones are you saying? No, or
Oh, I should count NoFX too.
Social Distortion?
Yeah, technically they're more of a rock band than a punk band, I think. But I don't know. It's just tricky, slippery. It comes back with definition. Let's not worry about that right now, though. So here's what we got. Here's what we got. We got 50 songs. Anybody know why I did 50? Otherwise, just torture Brandon while he's up there. That's one reason. It's the minimum I should have done. I should have done more, but I could tell Brandon was getting bored. There's an old rule that when you're studying proportions, you have to make sure you sample a minimum to actually observe enough of each of the elements of the population. Now, if there were 10 songs on this playlist, and we observed them, what's the chance I saw each song each time?
1 in 5.
Say that again?
1 in 5.
How about 1 in
Oh,
10? 1 in 10 songs. There's about a 1 in 10 chance I saw any given song on any given shake.
Yeah.
10%, right? So 0.1 as a percentage. I had Brandon do it 50 times. 50 times 0.1 is 5. And this is something I don't expect you to memorize. I don't want you to memorize. You probably forgot that already. That's the minimum number of trials when you're testing a proportion that you need to test to make sure you see enough of those objects in the population. If there were 100 songs in the playlist, which they're not, thank God, but if there were 100, that would mean there was a 0.01 chance of seeing each one. So we'd have to do 500 shakes to ensure enough shakes to actually see all the songs on average 5 times. Everybody's seeing, we should, if this was a perfectly randomized algorithm, and we shook it 50 times, there should be 5 of each of the songs in there, correct? 5 of the first, 5 of the second, 5. As it turns out, only Maiden and NoFX saw exactly 5. We saw Billy Bragg came in at 3. We had a good Queen day. They came in at 8. They're just as much over as Billy Bragg was under. Make sense? So the question now is, does this appear random enough? It's no longer a shuffle. Thank you, Sean, for that. That was a good distinction between shuffling and randomizing, because they are 2 different things. We've eliminated the need for a shuffle. One thing I love about this, though, there's still something that bothers me. We never heard a song followed by itself, did we? And I've never heard a song followed by itself with a 10-song playlist. And I don't know if it's too much to expect over 50 shakes. Maybe. I've never tested that part. But let's just talk about total occurrence of the songs. Is 7 Pat Benetars, 4 Refused, 4 Anthrax Public Enemy, 3 Billy Bragg, and so forth. Is that random enough? Elizabeth says yes, Chris says looks like it, good. How would you quantify that? Can you quantify that for me? Because when you have a theory like that, yes, it looks random enough. So I think we already have a hypothesis. If you, I'm gonna put this back up in a second.
If you rearrange it, it's function.
So, say that again. Hold that thought. So I think let's come up with our hypotheses before we even start testing. We have time for a hypothesis, maybe at the beginning of a crunch. So here's the iPod randomizer. iPod random. Your guys' claim is that the iPod's random enough. So mathematically, what are we going to test?
Percentage?
Yeah, I think since you guys went right to that, you told me it was a 1 in 10 chance, we're going to be testing percentages. We're going to be testing percentages, the percentage of the time that we heard each of the songs. Does that make sense? So P1 would be the percentage of time that we saw Pat Benatar. P2 would be the percentage of the time that we saw Refused. P3 would be the percent. Notice how they're all, I'm making them all equal. Is that okay?
No.
How come?
Because they are random.
But
They're shuffled.
But over the long period of time, what does random purely mean from a probability standpoint? How often should we hear Pat Benatar? 10% of the time. How often should we hear Refused?
Okay.
10% of the time. No, Elizabeth, what you're saying is beautiful. I'm not saying on a short run I should see them exactly 5, 5, 5, 5, 5. But it's going to average out over time that we're going to see them each 10% of the time. Is that fair? So that's why, and just to save ourselves some time, we'll just go equals P sub 10, which equals 10%. Is that fair? So that's going to be, you know what, that's actually our null hypothesis. More than a definition of the variables, isn't it? I'm sorry, by putting a 10% in there, That's actually the null hypothesis. It's random enough, isn't it? It's random enough. What if it's not? What would that look like? If you had to write that out, what would that look like? It's not random enough.
Just put the not equals.
Yeah, that would be, where would you put the not equals?
10%.
Oh, okay. Mathematically, yeah, why not? That bothers me though. It bothers me only because we've got too many equal signs and then a not equal sign. That's what bugs me. How can we use the not equal sign? I got it.
Do it in between all of them?
Well, that's not necessarily true either. Because it's not that they all have to be off, it's just that somewhere something is off. It might be, remember how we had a spike at queen? Maybe we're hearing too much queen. But the other ones are only slightly lower, so they're not far enough away from 10%, but queen is. So I think I got it. It's not super mathematical, but I think it ties both your guys' ideas together.
P1 through P10 does not equal?
Yeah, I think so, Chris. At least one. No, here's the deal. Ben's got a very, very good question. Don't we have the hypotheses switched around? It seems like we do, because our claim was that it's random enough, right? Our claim was that it's random enough. But what's easier to build a null curve around? What we know it's supposed to be like, or something that we think it might be like? That's the question you have to ask about null hypotheses. It's easy to build a curve around 10%, because we know if it's supposed to be 10%, we know what that curve is going to look like. The problem is, if at least one isn't 10%, what is it? Is it higher? Is it lower? Is it off? How much more than 10% is it? So this is the first time you guys have actually made a claim. Most of my classes actually say, yeah, something's off. There was too much queen. There was too little Pat Benatar or something along those lines. So the claim most of my classes make is, no, it's not random enough. It's too unrandom. So that's the claim I usually hear. The trick is, not random enough represents a deviation from status quo. Is fair enough? So Ben's got a very good question. It seems like I put this in a strange place, because that was the claim Elizabeth made, and usually the claims we make go here. But the research hypothesis always represents a deviation from what's expected. And what's expected, even if I want to show the iPod's not being random, we're going to assume it is for starters, and then show we've gotten away from that. Is that fair? Ben, great question. Great question. We're going to assume it's random at first, and then move away from that to finish. Show it is at first, and then move away. If it is, it might not be far enough away. It might be perfectly random. So if we get a big p-value, that means this guy. If we get a small p-value, that means this guy. Fair? That's the same as it's always been, and it always will be that same for these last couple of tests we do together. Fair enough, Ben? Great question. Other questions. That was a really good one. Other questions that are bothering you right now. So we're going to be analyzing. Oh, go ahead, Brian.
Hold it, just the random tied to the null. I mean, how does that apply? Because it's not random. I mean, I guess I'm having difficulty with that.
That's okay. That's okay. And the way we construct this test statistic is actually very, very different than we've constructed the ones in the past. And because there are so many, one way we can do this is by looking at the results. And hold that thought, Brian. One way you can do this is look at the results. Look at the results and say, okay, Pat Benatar came in at 7. So we saw her in 7 trials out of 50, correct? We saw her, I'm going to switch over here. We saw her in 7 trials out of 50, and we were expecting a 10%, occurrence of Pat Benatar. So I'm doing, if you will, I'm doing question number 1 on your exam. Single proportion. I knew it was supposed to be 10%, but I saw her 7 times out of 50. That's too high, isn't it? That's higher than 5 out of 50. So I'm going to test that Pat Benatar is too high. Okay, what does the TI say about it? It says, nope, she's not too high. 7 out of 10 is not too high. It's higher, but not significantly higher. Fair? But that's only Pat Benatar. Now I got to go back and check refused, right? And refused came in at 4 out of 50. Okay, 10%, 4 out of 50. That's too low, isn't it? That's too low. Was it too low? Not significantly. So now, Pat Benatar's okay, refused is okay. We could
Everybody's in between.
say that again.
Everybody else is in between.
Maybe, but why do I want to stop doing this right now?
Because it takes forever.
What? Because it takes forever? That's a good reason. I wasn't thinking of that reason. How many times I gotta do it?
10.
10 times, right?
Reduce your confidence.
What's my confidence after 10 single tests?
Really?
Oh God, 0.95 to the 10th power, yes? Okay, now I'm operating about 60% confidence. That's a bit of a problem, right? So what we want to do is view the entire set at once, yes? We want to view the entire set at once is what we want to do. The entire set viewed at one point. And that's where the goodness of fit test comes in, but we can't do it in 5 minutes. We'll have to pick it up on Thursday. So the idea is we have to make a comparison between what we saw, which is here, what we saw, which is there, and what we should have seen in a purely random assignation, which would be bars coming out right here. And measure that deviance and see if that is far enough away from what it should have been to be considered off. Pat by herself wasn't off. Refused by themselves weren't off. But then when you start mixing in Billy Bragg and Queen, are those throwing it off? So that's the trick with the hypotheses. It's not that they're all off at 10%. It's that maybe only one is off at 10%. Maybe 2 of them are off 10%. But the question is, you got to look at them all as one package deal and not in between. Just like we did with 2 samples. With the garlic versus placebo, that was 2 samples, we viewed them together. This is 10 samples all viewed together. But we can't, like I said, I can't do it in 5 minutes because the calculation takes a bit of subtraction and squaring. Ben, go ahead.
What's been going through my mind is that shouldn't enough trials, and it shouldn't matter if Queen's been played more, like you still are hitting that 10%.
If the randomizer's working.
Right.
See, that's the whole thing. If the randomizer's working, it doesn't matter that Queen got an early start. Because eventually what's going to happen down the road is somebody else will catch up to Queen. It's just like eventually, this is why you can't sit in a casino and watch the little old lady pulling the one-arm bandit. If she doesn't hit, that doesn't mean that you wait for her to get up and then jump in her seat and start pulling it, because the machines do. Randomness says you don't know when it's going to catch up. It's not going to happen immediately after she stops playing. So right away, Billy Bragg's not going to catch up to Queen, but eventually, if the randomizer's working, it's going to even out. But what if you can only do 50 trials? That's the thing. Do we have a tool for just 50? Go ahead.
What if Queen and Billy Bragg never catch up, but their extremes pull the average to...
That's what the test allows us to measure. That's the beauty of this test, is it allows us to look at those, combine with the other 8, and say, okay, that's too much of a deviance. Now, what you're saying is, when you say eventually, you actually need to then recalculate the data with more data points, which means Brandon's back up here shaking the iPod 50 or 60 more times, which is totally fine. I mean, it's worth doing. But on this data set, can we get anything? Go ahead.
I guess from a statistics standpoint, I don't see them being broken even if we get 30 Queens and 2 Billy Braggs, as long as the overall average still hits.
But the question is, over what number of shakes? In this case, 50. It all goes back. If you saw 30 Queens in 50 shakes, would you agree something might be wrong? Right. So that's the whole thing. Is 8 in 50... 30 in 50 clearly is too much. Is 8 in 50 far enough away from 5 in 50? But not in isolation when compared with the other 9. That's what we'll do on Thursday. Cool? Sound good? Okay. Good stuff. Good stuff. And that's what that last quiz you asked about is for. Should you choose to do it, Chris? Cool? All right.
So the p-value out there indicates that it is still random.
It's still random enough, exactly. We just haven't learned how to calculate that yet. Good, you saw that up there. Good for you. Changing, exactly. Very good. Well, I wasn't watching that. I was watching the trials under it. Did you notice how low it got?
I never saw it go below
0.5. Yeah, I wouldn't imagine it would either. Assuming that thing is behaving properly, which it generally does.
Yeah, I think the lowest I saw it goes to 0.6.
0.6 something. So it was getting to a coin flip and then it flopped back up. Good, good sir. Hi.
Hi.
Good.
Did I do that?
Probably. So you got P1. Is P1 relief from the people that got the placebo drug, and P2 is the ones that didn't get anything. So you're saying they got more relief. I love this. I love this. It's small, isn't it? So they did. It's small. It's a tiny p-value. Which what these doctors are trying to do was measure the placebo effect.
Yeah, and they're trying to say that it's at the
Well, to give somebody, right, but what this is maybe supporting is that maybe it's not. If it actually gives them relief, you could, even if they know what a placebo is, even if they know, isn't that crazy? I think it's totally crazy. Now the trick is, I know. It's all in their mind, but this is mind over matter. Maybe, right? Maybe it's mind over matter. The problem is, this is, and again, this is not a 244 question, it's a past 244 question. For a 3-patient bilateral trial, reported adequate symptom relief. What does that mean, right? What is it, self-reported results? I mean, did their fevers go down, or did they just think their fevers went down? Mind over matter again, right? Maybe the pain's still there, but their mind has convinced them it's not because they took something, put it in their mouth, and swallowed it. Does that make sense? But that's, again, not a 244 question. The 244 answer is, yes, look at that. It looks like the placebo group. It's completely weird. Yeah. Yeah. That's what's so surprising. I want to see this one replicated because it's very small, right? There were only 80 people, if I remember correctly. 80 total, right? It was Harvard Medical School. I love the study, except for the fact that it's a small sample, and the fact that you've got self-reported studies. But other than that, and maybe not well-defined symptom relief. Other than that, it's great.
So there's no, it hasn't been.
Not that I know of. It hasn't replicated. No. I hope it is someday. Yeah, good stuff.
Cool.
Yeah, I thought so. So what's up?
Are we turning more in?
Oh, poop. Bring him back on Thursday. I forgot to ask you guys about that shit. Bring him back on
All of us
Thursday.
want to.
Should have answered the question when I asked.
I'm sorry. Are we all still here? People left.
Yeah.
Can we bring him back on Thursday, and we'll turn either that one or the M&M one or this one we're doing right now in. How's that sound?
Are you changing the due date on the
I will if somebody
project?
reminds me.
I emailed.
Good. Then yes, I am, Eric. Yes, I'll push everything back to Saturday. We just did partially yesterday and partially today. So we did it in the Monday, Wednesday class yesterday. We did that actual dialogue. Sure. Yeah, 10:15? 10:15? Yeah, come on. For sure. Harry, MODOK, second floor. You'll hear me. You'll hear me. Actually, it won't be right at 10:15. Aaron, I take that back. Probably closer to 11 because 10:15 we're going to wrap up the normal distribution first and then go into that at about 11. So take your time.
Last time I watched the Central Limits, the last day,
You got
I watched it over.
And that's right,
Like,
you were.
so much.
Yeah, there's a lot going
Charlotte,
on.
sick.
I know, yeah, I remember
So
that.
they-
I remember that. Yeah, come on by for sure. But wait till 11 because it's going to take a little bit for us to get going. Cool. Rocking. Ryan, what's up?
I got the chart in front of me.
Oh, excellent. Look at you. Yes, please.
Okay, so obviously type 2 error goes away as they separate.
As they separate.
But type 1 error, that's only going to be associated with the coma.
Correct. So in other words, as this curve moves, type 1 error is not going to. Because this is type 2. Right, as you said, this is type 2 error. You got it.
And then my question is, what exactly causes them to separate?
That's the thing. Is
Going on
they are different. Now, what you're doing is you are examining all possibilities as they separate. They don't actually move, especially the way you're making them move.
No, when I say what is the circumstance that makes them wider versus